Hello, my dear students. Welcome back to my new class. In the previous session, we studied the data structure and its types. I hope all are studied in this topic, right? I hope that you should follow my topic regularly. And at the end of each session, I will give you some assignment that you have to complete within the regular time. Okay. Today, I discuss the topic time and space complexity and Bitcoin notation. First one is algorithm. What is an algorithm? Algorithm is a set of instructions to perform a particular task. Algorithm is not the completed code just for the logic, which can be expressed pseudocode or flowchart. A complete program is the combination of algorithm plus data structures. Each and every algorithm must satisfy the following properties. First one, input. We already studied what is input. Input is anything we were entering to the computer through our keyboard or mouse or any input device. Second one is output. There should be at least one output. Then definiteness. Each algorithm should be clear and well defined. Finiteness. Algorithm should have limited number of steps. Correctness. Each step must generate correct output. A good algorithm must satisfy these 5 properties. Next, an algorithm takes less execution time and less memory space. Then the algorithm is efficient one. The performance is measured based on 2 properties, time complexity and space complexity. What is space complexity? The amount of memory space required by the algorithm during its time of execution. In our computer, we have limited memory. So, space complexity is a serious issue for multi-user systems. An algorithm requires space for 3 components. First one, instruction space. It's the space required to store the executable version of the program. For example, our program is large, we need more instruction space. Program is small, we need less space. It's depend upon the number of lines in the program. Second one is data space. Do you remember what is data? Yes, it's the space to store all the data like constants, variables, temporary variables, etc. Next one is environment space. It's the space to store all the environment information. Do you clear space complexity? We have 3 spaces. We need instruction space, data space, and environment space. Okay. Next property is the time complexity. That means the time required by the program to its completion. Do you understand the concept of time complexity and space complexity? Next, our problem is the time-space trade-off. ഒരു പ്രോബ്ലത്തിൻ്റെ ബെസ്റ്റ് സൊല്യൂഷൻ എന്നത് വളരെ ചുരുങ്ങിയ സമയത്തിനുള്ളിൽ കുറഞ്ഞ മെമ്മറി സ്പേസ് എടുത്തിട്ട് എക്സിക്യൂഷൻ കംപ്ലീറ്റ് ചെയ്യുക എന്നുള്ളതാണ്. ബട്ട് ഇറ്റ് ഈസ് നോട്ട് പോസിബിൾ. ഒന്നുകിൽ ടൈം അതല്ലെങ്കിൽ സ്പേസ് സാക്രിഫൈസ് ചെയ്യേണ്ടതായിട്ട് വരും നമുക്ക്. ഈ ഒരു പ്രോബ്ലത്തിനെയാണ് നമ്മൾ എന്തെന്ന് പറയുന്നത്, ടൈം സ്പേസ് ട്രേഡ് ഓഫ് എന്ന് പറയുന്നത്. ഒരു അൽഗോരിതത്തിൻ്റെ എഫിഷ്യൻസി മെഷർ ചെയ്യാൻ 2 പോയിൻറ്റ്സാണ് രണ്ട് ഫീച്ചേഴ്സാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്, ടൈമും അതുപോലെ സ്പേസും. ഒന്നുകിൽ ടൈം കൂടിയാൽ സ്പേസ്, ഏതെങ്കിലും ടൈം അല്ലെങ്കിൽ സ്പേസ്, ഇതിലേതെങ്കിലും ഒന്ന് സാക്രിഫൈ ചെയ്യാതെ നമുക്കൊരിക്കലും ഒരു പ്രോബ്ലം ബെസ്റ്റായിട്ട് അല്ലെങ്കിൽ ബെസ്റ്റ് സൊല്യൂഷൻ ഉണ്ട് എന്ന് നമുക്ക് പറയാൻ പറ്റില്ല. The next topic is Big O notation. What is Big O? Big O notation with a capital letter O, not a zero, also called land use symbol. It is a symbolism used in complexity theory, computer science, and mathematics to describe the basic behavior of functions. Basically, it tells how fast a function grows or declines. Landau symbol comes from the name of the German mathematician Edmund Landau, who invented the notation. The letter O is used because the rate of growth of a function is also called its order. It is determined by the size of inputs. The types of measurements. First one, best case. When an algorithm takes less runtime with respect to the given inputs. It's also called best case algorithm. Second case, average case. Algorithm takes average runtime. Worst case, algorithm takes higher runtime as compared to the given inputs or data. Look at this picture. The chart represents the complexity. It may be order of log n, order of n, order of n log n. I hope that you would understand. In our next class, we shall be talking about strings. Okay? Thank you.